Assalamualaikum warahmatullahi wabarakatuh. Today we're going to present our discrete group project. So this is our group member, which is Nur Syahada binti Mukhtar, Nur Alisha Frizana binti Azhar, Nur Ala Shakira binti Abul Jalil, Nurul Batrisha binti Anwar, and lastly Nur Bahiyah binti Daud. For our chosen project, we focus on the properties of relation, which include reflexive, symmetry, and transitive relation. We choose the topic because it is a fundamental concept in discrete and is widely used in a computer science application. For example, relation properties are applied in database system, graph theory, and network analysis to represent and analyze connection between elements. Through this project, we develop a program that automatically determines the properties of a given relation and generates the required closure, helping us better understand this concept in a practical way.
The problem statement of our project is, in the study of discrete structure, understanding the properties of relations such as reflexivity, symmetry, and transitivity is essential for analyzing data relationships and building efficient computer systems. However, checking these properties manually can be time-consuming, complicated, and prone to human error, especially when dealing with large sets of data. Students may find it difficult to accurately determine whether a relation satisfies these properties and to construct their respective closures. Without a systematic and automated approach, the process of analyzing relations becomes inefficient and unreliable. This can lead to inaccurate conclusions and affect the understanding of important mathematical concepts. Therefore, there is a need for a computerized solution that can automatically identify the properties of a relation and generate its reflexive, symmetric, and transitive closures in a fast and accurate manner. This project aims to address this problem by developing a C++ program that simplifies the analysis of relations, improves accuracy, and helps students better understand the practical application of discrete mathematical concepts.
So next, I'm going to do some solution demonstration. As you can see here, we use C++, and at first we put our header here, and we make some welcome message, and we also made some declaration. So this coding, we ask the user to put the number of relation. So if the user enter number of relation equal to 0, so this kind of output will show to the user. Next is we make some looping. You want to check if the element in AB exists or not, and if not exists, then it will store. Also we want to check if the element B in AB exists or not. So the second is reflexive. So for every element, we want to check if AA exists or not. So if it exists, then it is reflexive. If any AA is missing, then it's not reflexive. Then is symmetry. Also, we want to check if AA exists, then BA also need to exist. And if missing symmetry is bare, then it's not asymmetric. And that is transitive. So if AB and BC exist, then AC should exist too. And the AC doesn't exist, then it is not transitive. So this is our output for properties of relation. It will show either yes or no. And this is our reflective closure. So at first it will print all the original relation, and it will also print the missing element in reflexive. Also, to the symmetry closure, it will print all the original relation, and it will also print the missing element in symmetry closure. So that is our transitive closure. So if AB and BC exist, then AC should exist too. So we need to check if AC already exists. If missing, it will add the missing element. And last but not least, it will print all the relation. So we want to check our final output. So as you can see here, this is our message, our welcome message. And I want to enter 6 relation pairs. So 6 enter. First one is 1, 1, 1, 2, 2, 2, 2, 3, 3, 1, and also 3, 3. So as you can see here, the properties of relation is reflexive, but it's not symmetric and also transitive. So why it is reflexive? Because we have 1, 1 here, 2, 2, and also 3, 3. And it is not asymmetric because we have 1, 2 here, but we don't have 2, 1. Same to the transitive one, we have 2, 2, and also we have 3, 3, but we don't have 2, 1. So that's all from me. I will pass to the next presenter.
So to conclude our presentation, I will now summarize the final results of our project. So first, regarding our findings, after developing this system, we found that using C++ to identify relation properties is much more accurate and efficient than doing it manually. And our program successfully identifies if a relation is reflexive, symmetric, or transitive instantly. We also found that the transitive closure logic is the most vital part of the system because it ensures that all logical connections within a set are properly completed. Next, the lessons we learned. This project taught us how to bridge the gap between abstract mathematical theory and practical programming. We also learned that every line of code must follow strict logical rules to match discrete structure principles. And additionally, we realized that working as a team and documenting our code with comment is essential for solving complex algorithmic problems together. Finally, for our future recommendations, based on our experience, we suggest that this system could be integrated into database software to help maintain data integrity. So for future improvements, we recommend adding a graphical user interface, which is GUI, to make the system more user-friendly for non-programmers. We also suggest implementing Warshaw's algorithm in the next version to handle much larger, more complex data sets more efficiently. In short, this project has greatly deepened our understanding of the mathematical foundations of computer science. We would like to thank our lecturer, Sir Khairul Nizam, for his support throughout this course. Thank you for watching our presentation.
Next, I am Nurbahia Muhammad Dawood will tell you about project limitations. As you can see on the screen, although this project successfully analyzed the properties of relations and generates their closures, several limitations still exist. Firstly, the system is designed to handle only a limited number of relation pairs and elements due to the fixed size arrays used in the program. This restricts its ability to process very large datasets efficiently. Second, the program uses a command line interface which may not be user-friendly for all users, especially beginners who are more comfortable with graphical interfaces. Users must enter data manually, which increases the possibility of input errors. The third, the program does not include advanced error handling or input validation. Incorrect or invalid inputs may cause unexpected results or affect the accuracy of the output. The fourth, the transitive closure process may become slow when dealing with a large number of relations because it relies on nested loops. This reduces performance and limits the program's scalability. The last one, the system focuses only on basic properties of relations and does not support more advanced features such as database integration, visualization of relations, or support for weight and directed graphs. And that's all from us. Thank you.